All right, real world problem. What we do with this, first thing I'm going to do is teach you how to read an equation, what it means. Okay? So, you get a pen here. All right? In this equation right here, there's two important numbers in that equation. Okay? And those important numbers tell us something. The first one is the slope. Okay, we know that is slope. But it also means, that's what they call the rate of change. Okay? We want to know his rate of change. That's going to be important to us here in a minute, okay? So what it means, okay, is that every time I have an equation like this, like y equals 2x, that means every time I put a number, change my number for x, my y value goes up 2 times. Okay, so if I put a 1 in for x, my y is 2. If I put a 2 in for x, my y is 4. If I put a 3 in for x, my y is 6. So this tells me how much my y changes each time. This is what they call rate of change. How much that y is changing. Okay? So when I see the equation, I can tell by when it asks me how much the change is, I can look at the slope and know that's the change. How much it changes each time. Every time I put an x in, it changes by a value of 2. Okay? That make sense? Okay, now, the other number we all look at is the b number, which is my y-intercept. Okay? Now, the reason it's so important to look at the y-intercept is because that y-intercept has that 0 in the x-coordinate. And that 0 means a lot. It means where things start. Okay? Before you got up in the morning, you were at 0. You hadn't started the morning yet, so you were at 0 then. Before you walked through my door and started class, we were at 0. So the starting point is always 0. Okay? That makes sense? So the y-intercept not only tells us where they cross the y-axis, it tells us where 0 hits on the y-axis. So if I look at this equation right here, and it says, hey, let y represent the total cost of publishing a book. So y is my total cost. Let x represent the number of copies of the book printed, and y and x related. Well, when I ask this question, it says, hey, what is the change in total cost of the book printed? Well, the change is $12 every single time I print a book. Okay? Because what happens is, there you are, okay? When that book is printed, okay, if I print it, costs $12 per book. So every time the cost goes up, the number of books I change. If I change that from 1 to 2 books, I've just added $12 more to my cost, my total cost. And so the rate of change is what that 12 is right there. So the change for total cost, so the change word is always my slope. Okay? When it says change, that's always my slope or my rate of change word. Okay? Now, the other question says here, what is the cost to get started before any books are printed? Well, that's my intercept. So there's pre-production costs of $975. What would those pre-production costs be? Well, I'm not a book printer, but I'm thinking it'd be, okay, things like getting the book typeset, getting the artwork done for the cover, those kind of things. Those are pre-production costs. And then once that's done, it costs $12 per book to print and bind that book. Okay? So my pre-production costs are $975. So the equation will tell us these numbers. Okay? This is called the 0 question. Okay? Before any books are printed, we're at 0, which means 0 is the y-intercept. Okay? I call that the 0 question. And this is my change question. Change is always my slope. 0 is always my y-intercept. Okay? Does that make sense, everybody? So like I say, that equation can tell us a whole bunch if I look at that equation. Okay? Questions on that one? All right, we'll play with that a little bit later. Here we go. This is the fun one right here. This next one's the fun one. Okay? We get to read the graph. Okay? All right, so the graph represents this story. It says each day, Logan earns a fixed wage plus extra money for every hour overtime he works. The graph shows his total pay in dollars versus the overtime that he works. Okay? So, if we look at this, okay, this total pay is on the side, this is the y-axis, and his overtime hours are on the x-axis. So when he works zero amount of overtime, no overtime at all, he gets paid $60 per hour. Okay? Now, if he works 1 hour of overtime, so we go to 1 hour of overtime, his pay will go to $105. Well, how much did that change? He was at $60, it went up to $105. What was the change? Anybody know how much it went up? $45. There we go. So it went up $45 for 1 hour of overtime. Well, if he works 2 hours overtime, he goes up to $150. So that's another $45. So his rise is $45. His work is one more hour. Okay? So, let's see what the questions ask. It's all right here in the graph, by the way. What is Logan's pay with 0 hours of overtime? Well, find the zero line. Go up, there's my answer right there, $60. Okay? $60 with no overtime. Okay. As the amount of overtime increases, the total pay increases or decreases. What's true? That's going to be one that your pull-down menu is going to have an increase or decrease. So as the amount of overtime increases, so as time increases, pay is going up also, right? So it's increasing. Okay? All right. What is the rate? At what rate is the pay increasing? Well, we figured it was $45 per hour. We went and found that out. So we're going up $45 an hour. Okay? Now let's see who's got. Anybody write me the equation of that graph? All the numbers are there. Can you write me the equation? You know the slope? Slope is the rate of change. How much is it changing each hour? What's the intercept? Where does the 0 hours hit? So what's the equation then? There you go. That'll be the equation for that graph right there. Because it has the slope and it has the intercept given to us out of that chart. Okay? You okay with that? Everybody good on that? Okay. Questions? Oh, my 5's kind of wimpy right there. Okay, let's go to the next one then. Next page. Okay? You should pay attention because it's going to get kind of weird here. Okay? All right. Now they want us to graph the equation ourselves. So they gave us a couple of things. We'll call this K, but I'm not sure what it really is. K and Boston did a road race. K began the road race before Boston, but they're doing it by check time, so they passed various checkpoints. Here's their times. K's time is the X coordinate. Boston's time is the Y coordinate. And these times are simply right here. So they want us to put these times on this graph over here. So I'm going to take and go at 4 and 7. Here we go. So we'll go to positive 4, go up to 7. Looks like that's the point right there. There's my first point. My second point is at 5 and 8. My third point is at 6 and 9. And my fourth point is at 11 and 14. Right there. Okay? All right, so we've done that. We've plotted the ordered pairs. Now they want us to write an equation relating these together. Okay, so what does that mean? Okay, you said it's going up by 1. What does that mean? What is that? Is that a rate of change? Then that's the slope, right? So, oh, I did? Oh, okay. Not that one. Okay, sorry. Graphed it wrong. It's easier on Alex to graph those because you can see the lines where they fit. I'll show you what I mean in a minute. Okay, so you said my slope is 1. Okay, right? Everybody agree with that? Okay, this goes up 1, right 1. Right? Up 1, right 1. Up 5, right 5. Is 5 divided by 5 still not 1? The ratio showing. Now, that's one way to find slope. The other way is to go over here and say, hey, this is up 1. This is up 1. This is up 5. That's my rise. Over here, this goes up 1 over here. This goes up 1. This one goes up 5. The ratio is still 1 to 1 or 5 to 1, still the same ratio. Okay? Now, here's the hard question. They want an equation, though. So I know the slope. Do I know the intercept? You remember, your equation, there are two choices. You can know the intercept and use that equation over there, y equals mx plus b, or you can know a point and do that equation over there. Which equation would you like to do? I think I'll do that one over there, because I have a point. I don't know my intercept. My intercept would be where the 0 line is. 0 line's right here. I don't have a point on that line. So I'm going to go over here and find my intercept. Here we go. Ready? Which point you want to use? Madison, I'll give you the choice. Which point you want to use? Any one you want. You're not even on Madison. 4 and 7. So we're going to use this point right here. Okay? All right. So here we go. Remember, in this equation, we're going to put it in point-slope equation. This one right here, y minus y1 equals m times x minus x1. We're going to put it in that equation. Can't see it. It's up there. Okay? And we put the point in the equation. What happens to my point? I'm putting my point into the equation. I got to do what to my point? Change the sign. Remember? So I'm putting into the equation. I got to change my sign. So my equation is going to be y. This is a positive 4. Oh, sorry, positive 7 on the y. So I have to put it in as negative 7 equals my slope. We said our slope was 1. That's going to be kind of simple to work with. Parentheses, x. Now I put in my x coordinate, which is positive 4. So it goes in as negative 4. Okay. Now I solve this. Get this thing solved. Okay. So I think I'll times that through. 1 times that is still 1. So I get y minus 7 equals x minus 4. Because 1 times x is x, and 1 times 4 is 4. Then I'm going to add 7 to both sides. And I get y equals x plus 3. Okay. That's one way to find it. There's another way to find it. Okay? Use your graph and continue your slope. See how the slope goes up to the right, up and right 1? We'll go down 1 and left 1. That'll put me right there. Down 1 and left 1 puts me there again. Down 1, left 1 there again. And down 1, left 1 puts you right there. But my intercept is, by the way, positive 3. And I could write that same exact equation. Okay? So, guys, if you can get your intercept by following your slope, that's great. And it doesn't matter which way it goes. If the line goes this way, it's got to be negative, okay? Remember that? But if I get to my intercept, it's great. But sometimes the line's over here and you can't get to your intercept, which is okay. Just go do point slope. You have 4 points to work with. It doesn't matter which point you use. Just go to point slope. Okay? Everybody okay with that? Okay. I get lots of questions on that point. I get lots of questions on that. I get lots of questions on how to do that question. Okay? All right, here we go. This is going to be more fun. Okay? Connor is adding water to a swimming pool at a constant rate. The table below shows the amount of water in the pool at different amounts of time. Okay, so my first question, I want to know this question first. How many gallons per minute is he adding to the pool? Okay, here's how I find out. Okay, water is going in how fast? I go from 112 to 148. How much water was added right there that time? 148 minus 112 is what? Not 26. 36. Okay? And this one goes up 36 too. And this one goes up 36 also. Okay? That's how much water, but this time limit is right here. This does that in 3 minutes. Right? And these are 3-minute intervals. Okay? So, gallons per minute is going to be 36 gallons in 3 minutes.
36.
So, the gallons per minute is 12 gallons per minute. Are we okay with that now? Okay. Now, if you figure that out first, the other one's kind of easy. Okay? But here's what they want the other one. On the other one, they want to know how much water was already in the pool when Connor started adding the water. So what they want to know is, when X was 0, how much water was in the pool? Okay, they want to know this number right here, when X is 0. Well, this is how you figure it out. Okay? He added, before we got to our first number, he has a total of 6 minutes right there, right? From 0 to 6 is 6 minutes. That means we go down here, and 6 times 12 is 72 gallons. So before we got to the first thing, he added 72 gallons to the thing before we got to our first number. We got to take the 112 and subtract out our 72 gallons that we added in that 6 minutes. That'll tell us how much we started with. So it's 112 minus 72 is telling me how much was left.
40.
So he started with 40 gallons of water in the pool. Okay? All right? That's how you find that. So you have to do a couple of numbers to work together, okay? You can do it all at once. You can do it in intervals. I don't care if you do it in units of 3 or all at once, okay? But you got to take that water back out that he put in 6 minutes worth. So find your gallons per minute, times it by how many minutes you got to put it in. That tells you how much water was added to the pool. And you got to take that back out to how much it started out with. Okay? That make sense to everybody? Everybody okay with that?
Yeah.
Okay. You're going to get a couple of those. They can be kind of freaky, so got to be careful on those. Okay, last one. We're just writing this equation. So, but I'm thinking we need to find Abby, because Abby tutors 9th grade math. And we have some kids in here who need a tutor. Okay? And by the way, Abby's cheap. Abby's only charging $35 an hour. Okay? If you hire me as a tutor and I come to your house to tutor you, I'm charging $50 an hour. Yep, and so the minute I hit your front door, you hand me $50. First hour is off 1 hour minimum. Okay? Yeah, that's not bad. Okay? Okay, tell you what, but here's the deal. Okay, my thing is pretty good, okay? You want to save $50? Okay? If I come to your house, $50 an hour. If you come to my classroom, before school, after school, and before intervention, it's $0. Okay, so all you gotta do is show up here and you get free tutoring for cheap, for free. Okay? If I come to your house, $50 an hour to walk in your front door. Okay? Now if I plan this right, I'll do 2 and 3 at the same time, so I'll get like $150, $200 an hour. Yep. Okay? We're going to do this 20 minutes. Okay, so now we're going to write this equation. Here we go. So, guys, when I see this thing right here, it says let E, that's where I start my equation. So I start my equation with E equals. Then it says she's earning $35 per hour, so I just go 35H. There's my equation. Then they want me to use my equation, so I'm going to take my calculator and go 35 times 14 hours is how much money? Have we got a calculator going? $490? That's pretty good wages for 35 hours of the work. That's about a week's pay. That's not bad. Okay? Yeah, go be a tutor. Don't have a problem with that. You have to know math. Okay?